Hey everyone, and welcome back to Mr. Fisher Helps Me with my homework. Today we are going to do 6.3 parallelogram. Try to make it sound like a question. Whether or not this is a parallelogram, it's going to be two choices. It's either going to be yes, it is a parallelogram, or no, it is not a parallelogram. So let's take a look at the theorems that say, hey, it is, or hey, it isn't. So here are my four theorems. So the first one, 6-9, says that if opposites, or if the diagonals bisect each other, then it is indeed a parallelogram. 16 says if opposite sides are equal, it is a parallelogram. If opposite angles are equal, then it is a parallelogram. And if one side is equal and parallel, it's a parallelogram. So let's take a look at some practice problems. Okay, here we go. So, is this one going to be a parallelogram? Well, it looks just like in our notes 612. So I'm going to say yes it is, because one side is equal and the same side is parallel. The second one, opposite angles are equal. Is that in our notes? Let's check. Yes it is. It's right here. So I would say, yes, it is a parallelogram. Opposite for this one, the opposite sides are equal to each other. Does that make it a parallelogram? Yes or no? Let's check your notes. Yes, it does. So I'm going to go ahead and say yes to that one. And I'm going to let you figure out the other ones. This one here is definitely a no. This one here is definitely yes. And this one here is a resounding no. Okay, let's look at the next ones. Now, the coordinate ones are very weird because they deal with this thing called midpoint. Okay, midpoint is all about the middle. So the formula that we need to know for this is going to be x plus x divided by 2, y plus y divided by 2. Okay? If this matches with the other one, then it is a parallelogram. So let's do an example problem. So P and S is going to go first, and I'm going to do that in blue. So I'm going to take x and x, so 0 and 7 divided by 2. And then I'm going to take 0 and 4, my y, and then I'm going to divide by 2. Then I'm going to do Q and Y in red. I'm going to take 3 and 4 divided by 2. I'm going to take 4 and 0, add those, and divide by 2. Now let's see if they match. 7 divided by 2, 4 divided by 2. This is going to be 7 divided by 2, and this is going to be 4 divided by 2. Holy cow, they matched. So yes, it is a parallelogram. So let's look at the next one. Same thing, I'm going to do S in blue and T in blue. So negative 2 plus 2 divided by 2. I'm going to do 1 and 0, so 1 plus 0 divided by 2. And then in red, I'm going to do R and Z. 1 plus negative 1 divided by 2. I'm going to do 3 and negative 2, so 3 plus negative 2 divided by 2. So I simplify. Negative 2 and 2 make 0, so it's going to be 0 over 2. 1 plus 0 is 1 over 2. Then I'm going to do 1 plus negative 1, which is 0 over 2, and 3 minus 2, or 3 plus negative 2, is 1 over 2. And yes, they match. So it is a parallelogram. Okay. And the last one, W and Y, I'm going to do 2 plus negative 2 over 2. I'm going to do 5 and negative 3, so 5 plus negative 3 over 2. And then in red, I'm going to do R and N. 3 and negative 3. 3 plus negative 3 over 2. And 3 and 1. 3 plus 1 over 2. Okay, so let's simplify. 2 and negative 2 makes 0 over 2. 5 and negative, I think it's a negative 3, right? Let's check down here. Negative 3, yep. So 5 and negative 3 make 2 over 2. Over here, it's going to be 3 and negative 3, which means it's going to be 0 over 2. Oh, it's looking good. 3 and 1 make 4 over 2. They do not match. So no, they are not parallelograms. Now let's take a look at the review from the last time. Look at these. Remember, diagonals are equal to each other. Remember, sides are equal to each other. Well, down here too. So x plus 20 is going to equal 3x minus 14. And 3y plus 2 is going to equal y plus 20. And in order to solve this one over here, opposite angles are equal. So 4x minus 35 is going to equal 3x plus 10. And 2y minus 5 is going to equal y plus 15. Okay, I hope that I helped you out. I hope you're able to determine, is it a parallelogram? Yes or no? Thank you.